Hi folks, welcome to the solutions for the formative calculus assignment for Math SL12 in 2022. We're going to find some limits. The first thing that we try and do is just sub in. So can I sub in this one? Let's see, if I put in 3, I'll get 2 times 3 squared minus 3. Oh yeah, there's no problems there, which is 2 times 9 minus 3, or 18 minus 3 is 15. Okay. We could also look at the graph and you'll see that its y value at that point. It goes towards 15, but also it actually is 15 there. There's no problem. The next one, if I sub in, I'll get 0 over 0. So that means that there may be a limit. We just have to get fancy. And to do that, we have to factorize. So lim as x goes to 0 of, I can take out a greatest common factor on the top. And now I can divide out those x's. Remember, I keep my limit notation until I sub in. And my problem's gone because I divided by almost 0, not actually 0. And now I sub in, and I get negative 3. Okay. In the next one, if we sub in, you'll get 4 minus 4 on the top and 2 minus 2 on the bottom, so 0 over 0. Again, it's indeterminate form, so we don't just give up. We see if we can figure out some way to move forward. I can factor the top. I can see a factor that can divide out, x minus 2. So I'll do that. You can get away with all this stuff in limit land. And then sub in. Okay, so this isn't saying that the y value is 4 when x is 2. It's saying that the y value goes towards 4 as x goes towards 2. The equations of horizontal and vertical asymptotes. So the vertical asymptote is going to be x equals 5. The horizontal, then that should say y equals. The horizontal would come from looking at the limit as x goes to infinity of the whole thing, and we only really need to consider the drivers. So as x goes to infinity, we get 2, so the horizontal asymptote is y equals 2. Okay, we have to write them as equations, and you don't need to label that they're horizontal or vertical, because y equals a constant is guaranteed to be a horizontal line, and x equals a constant is guaranteed to be a vertical line. Next one, we're going to find a derivative using first principles. So I know this over here. So off to the side, I'm going to have to find f of x plus h, which would be x plus h all squared. I'm just subbing in x plus h for x, minus 2 by x plus h. That's going to give me x squared plus 2xh plus h squared minus 2x minus 2h. Listen, we already know that the answer is going to be 2x minus 2 times 1. Okay. But we want to show how we get there. So f prime is going to be lim as h goes to 0 of f of x plus h. Okay, that would be the stuff in red. X squared plus 2xh plus h squared minus 2x minus 2h minus f of x. And f of x is just this over here, which is x squared minus 2x. And that's all over h. You can see some terms are going to add to 0. And we'll be left with lim as h goes to 0. Maybe I'll keep writing f prime of x here, of 2xh plus h squared minus 2h all over h. I can factor, because I still can't just sub in 0 for h. So that'll give me 2x plus h minus 2 on top. And an h on the bottom, those divide out. F prime is the lim as h goes to 0 of 2x plus h minus 2. Sub 0 for h, and you get 2x plus 0 for h minus 2. Or, as we expected, f prime is 2x minus 2. So we're not surprised at the result here. We could find it through simple rules of differentiation, but it's asking us to use first principles here. The next one, we're going to differentiate. So 3 stays, it's a coefficient. X to the 4 turns into 4x3. Minus 2 stays, it's a coefficient. X squared becomes 2x to the 1. A 1 becomes, or an x becomes a 1, rather. And a constant term becomes a 0. You can use any notation for the derivative here that you like. So you could use y prime, or you could use dy by dx. There we go. There's a result. In the next one, if I want to be able to do this, I probably have to rewrite it in exponential form. I could do it with some quotient rule with that 3 over x squared, but it's overkill. It's a lot easier here to go 2 stays, power comes down front, power goes down by 1. Next term, negative 3 stays, power comes down front, power goes down by 1. And then just simplify. So 2 times a half is just 1, so we'd get x to the minus a half plus 6x to the minus 3. Full marks here. If you're feeling fancy, you could write this as 1 over root x plus 6 over x cubed. And that's optional, so either one. Or the next one, again, we probably need to write it in exponential terms. Okay. And then when we differentiate, we'll get 1 half 3x squared minus 2 to the negative 1 half. This is a chain rule, right? It's not just x to the power of a half. It's a whole glob or a whole inner expression. So that glob to the half is going to be half glob to the negative a half times the derivative of the glob. Okay. And the derivative of that inner part, 3x squared, would be 6x. We can put that half and the 6x together and get 3x. 3x minus 2 all to the negative a half. That's pretty. If you want to write it in radical form at the end, it would be this. And last one, we've got a quotient rule, right? We've got a function of x on the top, and we've got a function of x on the bottom. So 2x minus 3, that would mean that u prime is 2. V is x squared plus 1. V prime would be 2x, right? And quotient rule is u prime v minus uv prime all over v squared. So I'll just plug and chug. U prime v minus u v prime all over v squared. And now we'll just clean up that numerator. 2x squared plus 2 minus. I'm going to do the multiplication and I'm going to keep the result all in brackets here just because I'm scared that I'm going to botch it. So minus all of that. People will very often screw up the term or the sign of the negative 6x. But you can see when you subtract it all, it's going to turn into a positive 6x. Okay, minus 4x squared plus 6x all over x squared plus 1 all squared. I can keep going with this, collect my like terms. Y prime is going to be negative 2x squared plus 6x plus 2. If you really want to, you could factor out a common factor of negative 2 up top. Totally up to you. Okay. I think this is really good like this. The other steps leave a little bit to be desired, but they're not wrong. So x squared minus 3x. The form that you want it in kind of depends what you want to happen next, though you can see if you wanted to sub in a number, it's probably easier here. There's no factorization we can do up top, even if we wanted to, so that's as far as we can go. Number 5, find the slope of this, the tangent to this, where x equals 4. So one thing to notice is if I say this out loud, this function is the square root of x times 2x minus 5 all cubed. Oh my gosh. There are x's that are not separated by a plus or minus. That's a product rule. Okay. So I'm going to go ahead and define what u and v are in this case. So product is u prime v plus uv prime. So u is x to the half. U prime would be 1 half x to the negative a half. You can write that in radical form if you want. V is all of the rest. So it's 2x minus 5 all cubed. So v prime is going to be, it's a glob cubed. So it'll become 3 glob, or inner part, to the squared, times the derivative of the inner, which is 6. So v prime, or sorry, which is 2. Got ahead of myself. I'm multiplying, and then I get 6. Now I've got all those things defined. I can just plug into that product rule, which is u prime v 2x minus 5 all cubed plus u v prime 6 2x minus 5 squared. You could make it a little nicer if you wanted to, but since we're just going to sub in, it doesn't really matter how far you simplify it. So I might call this 6 x to the half 2x minus 5 all squared. Okay, there is a common factor here of 2x minus 5 all squared. There are ways to write this in fractional form. But really we want to know the slope where x equals 4. So sub 4 for x. So what will that give us? A half, 4 to the negative a half. I'm going to do the next part in my head. 2 times 4 minus 5. So that's 3 cubed. Plus 6, 4 to the half. And again, 2 times 4 minus 5 is 3 squared. And we'll just work this through. That would be a half times 4 to the negative a half is square root of 4, which is 2, but flipped, times 27. Here we have 6 times 2 times 9. Let's keep going. What will that give us? Y prime is going to be 27 over 4 plus 6 times 2 is 12 times 9 is 108. We need to put this together. You can either go to mixed numbers, you can go to decimals. It's okay with me if you go to a calculator here. We don't want to use any fancy calculator stuff to sort of avoid the whole technique altogether, but you could use your GDC to check, especially since this is an at-home assignment. So I'm going to go to a common denominator. 108 doubled is 216. Quadrupled is 432. And so y prime is, what, 459 over 4, which is equal to, let's see, 440 would give us 110, 114.75. Okay, either of these are good. So we've found the slope. Now we have to find the equation. To find the equation, we need a point and a slope, so that we can use what formula? You guessed it, the point-slope formula. I'm going to leave this as a fraction. I think it'll be easier if I'm working without a GDC. Okay. So for something, the y value here would come from subbing in 4 into the original. So 2 times 4 minus 5 is 3 cubed. So it would be 2 times 27, or 54. So here's the point. This is going to be kind of unpleasant numbers. But we could deal. They're probably more unpleasant than you'd get on a paper one. But since you're at home, you have the opportunity to use your calculator to help you with some of the drudgery. So y minus, or x minus 4 rather. So I'm using point slope formula. That'll give me y minus 54 is 459 over 4x when I multiply this through. And those 4s will just divide out, so minus 459. That's great. If it doesn't specify the version of the answer, you actually get full marks right here. If you want to put it in y equals form, we're going to have to add 54 to each side. And that will give us y equals 459 over 4x minus 405. Okay. If you're like me, you probably are not quite confident about this, so you'll head to decimals and just check it out. So here's the function. You can see that it is really high at x equals 4, so I might change my scale. Maybe you do that by changing your settings on a GDC. It doesn't exist to the left of 0 because you can't square root a negative number. Let's put in the equation of that tangent that we found. It does look like it is the tangent somewhere around here. And is there a point of intersection? Sometimes Desmos struggles with finding that point of intersection, by just tapping on it when it's only 1 point, but it is there. And if I go really close in on it, it's going to show me that point of intersection. Lastly, we're wondering about where the x-coordinates are, where this has a horizontal tangent. So that means where is slope 0? So let's differentiate. We get 3x squared plus 2x minus 1. And how we should read this, anytime it says f prime or y prime or dy by dx, that just means the slope or the tangent slope. So where is it horizontal? Wherever this is equal to 0. And let's find those x values, either through factorization or through quadratic formula. It does factor, okay, by guess and test or by decomposition. And it's going to have zeros at x equals -1, which you might have just been able to pick out from that bracket, and x equals +1/3, the thing that zeroes out the other bracket. Those are the key concepts that we've dealt with since the holiday break. I hope this has been helpful. Good luck with the material, folks, and take care.